Hi everyone, today in Integrated Math 2 we're going to go over Chapter 6 of Lesson 4. Here are the objectives. Make sure you write them down in your notes. Alright, let's go over our first postulate. Angle side angle, also known as ASA, congruence. If two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then these two triangles are congruent. So as you can see here, we have if angle A and angle D, so they're marked twice, if these two are congruent, and we also know that side AB and side DE are congruent, so that's marked with this line here on both. That's how we show congruency. And if we have angle B and angle E, which are shown as congruent here as well, then we have the two triangles that are congruent. Well, let's look at it again real quick. Angle, side, angle. Angle, side, angle. So perfect. And I know it's 1, 1, 1, 1, and 2, 2. And I'm talking about the number of lines. But also keep in mind that the order is also important, that triangle ABC, ABC, and it has to be in the same order for the other triangle. It has to be congruent to D, E, F. Then we have angle, angle, side, also known as AAS, congruence. So same idea, if we know that angle A is congruent to angle D, and we know that angle B is also congruent to angle E, and side BC is congruent to FE, we can see here that we have angle, angle, side. Angle, angle, side. Perfect. So we know that our two triangles are congruent. Our two triangles being triangle ABC, ABC, and DEF. There we go. So this is just reminding you, a little chart to remind you of all the different congruencies. We have side, 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 angle, side, angle, angle, side, angle, 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 side. And you can see with the markings too exactly how they are congruent. Alright, so let's go example 4. This time we're going to do a flow proof, which is just going to show you with arrows how it would go. So a little different than a two-column proof, but the same logic. First thing we want to see is that we are given that side PQ bisects angle RPS, and angle R is congruent to angle S. And then we want to prove that this triangle and this triangle are congruent. So first thing we want to do is go with our given. So I do know that PQ bisects this angle, and because of that I do know that this angle is congruent to this angle. And that's because of the definition of angle bisector. I know that RPQ is congruent to SPQ, because the definition of angle bisector means it splits it evenly perfect. So this is 20 degrees, this one's 20 degrees. Then, after I can't go any farther with that, then I go to my second given, which is angle R is congruent to angle S. So here I'm just going to mark it. 1, 2, has to be different from these ones. 1, 2. Can't do anything else with that. Wasn't given much information. Then I can see that I have this line that's similar between both of them. And this one's called the reflexive property. PQ is reflective with itself. So you just mark it once. And that's once it's different from the angle, this is a side one that we're marking. So if we're looking here, we can see that we have an angle, angle, side. Angle, angle, side. Well, that does prove congruency, so we are good. We're going to say that just like we said, we have proven that these two triangles are congruent by angle, angle, side. So I now know that triangle RPQ is congruent with triangle SPQ. And there we go.